Hello students, welcome back to our channel Physics Gallery. Asha Vino, this is your Asha teacher coming with a question from our chapter Electric Charges and Electric Field. Okay, so today we are going to do that question. So the question says that 2-point charges plus Q and plus 4Q are separated by a distance D apart in free space. And find a point on the line joining the two charges where a third charge capital Q will be in equilibrium. Okay, so it is given that two charges, this is our plus Q and this is our plus 4Q, and they are separated by a distance of D apart in free space. Okay, so the medium between the two charges is taken to be vacuum or free space. Find a point on the line joining the two charges. We have already drawn a line joining the 2-point charges, but that line may extend outside the charge also. The line joining the two charges will be like this. Okay, so this is the line joining the two charges. Okay, we have to find a point on this line where a third charge capital Q placed will be in equilibrium. So what is this equilibrium? Yes, we have studied when the net force acting on a system is, what is equilibrium? Yes, when the net force acting on a system is zero. We have studied when the net force acting on a system is zero, then the system is said to be in translational equilibrium. Straight line equilibrium, translational equilibrium. Okay, so we can consider the point in between the two charges on the line joining them, or outside the two charges, that is nearer to plus Q or nearer to plus 4Q. At first, we will take this point, that is a point in between the two charges. If I take the point, suppose it to be P, and we are placing the charge Q there, then when the force becomes zero, the force acting on capital Q due to plus Q and due to plus 4Q becomes zero. That means the force must be equal and opposite. Then only the force becomes zero. That is, we have to go to the direction. So we know this is plus Q, and since it is given as capital Q, it will be also plus. So what happens? Two like charges repel. So plus Q repels plus capital Q away from it. That is, the direction is towards the right. Similarly, plus 4Q also repels the plus Q. Like charges repel. So the direction is towards the left. So what happens? They are in opposite direction. So there is a chance for the force to become zero. Similarly, if I take a point P here, nearer to plus Q outside. Okay, so what happens? This plus Q repel plus capital Q. That is, direction is towards left. And what about the direction of force provided by plus 4Q on this plus Q? Again, plus 4Q repels plus Q. Again, the direction is towards the left. So, the two forces acting on capital Q is on the same direction. So, whether it cancels? No, there is no chance to get a point like this. Okay, where the force is zero. Clear? Similar, if I take a point nearer to plus 4Q outside the line, so what happens? Plus 4Q repels the charge Q kept at this point P, repulsion towards right. Plus Q also repels, so its direction is also towards right. So what happens? No possibility for a point to be equilibrium. Okay, is it clear? That means we understood one thing. When the two charges are like charges, the force will be, or the point where the net force becomes zero will be in between the two charges. That is, this is the only condition. So we will draw this once more. We will draw like this: plus Q, plus 4Q, distance D apart. Okay, and there is a point P where we have kept a capital Q, and we are assuming that distance is X. If this is X, we can write this as D minus X. Is it clear? And for the force to be zero, we have to write a direction is opposite. We know plus Q repels capital Q like this, and plus 4Q repels the capital Q like this. So direction is opposite. Now we have to equate the magnitude. Equal opposite force makes them zero. So we are going to take the magnitude of force acting on capital Q due to small q, and force acting on capital Q due to 4Q. to be equal. Then only the system will be in equilibrium. Equal and opposite forces. Opposite means direction is opposite and magnitude we have to make it equal. So the equation becomes, may I write 1 by 4 pi epsilon 0? The equation 1 by 4 pi epsilon to be K capital Q, Q1, Q2 by the distance between Q and capital Q is x square. So it becomes equal to K, first charge Q, second charge is 4Q by d minus x the whole square. What happens? K cancelled, capital Q cancelled, small q cancelled. Then the remaining, here we can write the remaining portion here, 1 by x square is equal to 4 by d minus x the whole square. Okay. All terms are square terms. So taking the square root, 1 by x is equal to 2 by d minus x. Okay, so we can write d minus x is equal to, from this equation, d minus x is equal to 2x, or x is equal to 3x, sorry, d is equal to 3x. From here, we can take x to be, finally, x to be d by 3. That is, this distance will be, the charge q will be kept at a distance d by 3 from plus q, so that the system will be in equilibrium. Or we may write the charge in capital Q be kept at a distance 2 by 3d from plus 4q. This is d by 3, then this will be 2 by 3d. Okay, clear? So hoping you will understand this question. Enjoy the question. Okay, see you.